A kite's on the end of a string, 80 meters long. Now, I'm going to pause there for a second. That's a really long string. You might notice I've already drawn up this rough diagram and I haven't put any information on it yet. I'm going to fill it on as I read the question, right? So, here's my kite up the top here.
Is it meant to be a kite?
There's my kite. It's flying up in the wind, okay? And the string that's attached to the kite is 80 meters long. And I think it also does mention, assume the string is a straight line. So, here is my 80 meter piece of string.
Is it straight meaning that straight?
Yeah, straight, like a straight line. Okay, yep.
Possible the one going up is the string?
No.
It doesn't
The
say
answer
that.
is
That's
no.
on the
The answer is no, because if you keep on reading, which let's do
No,
that.
I already did that one. I'm just saying it as an example.
In general, yeah. In general. If the vertical height of the kite, now we're talking about this distance. The vertical height of the kite from the person, from the ground, sorry, is 69 meters. So there you go. There's another length, okay? Now what's the actual question they're asking for? Find the angle of elevation of the kite from the person. Find the angle of elevation. So here's the person. Okay. So, which angle is the angle of elevation in this picture? Yeah, Lucas.
Is it the one on the left?
Yeah, it's the one at the person. On the left, I guess, is this is what you're referring to here. Okay. Right. So you remember we have these Greek letters, they're kind of our convention for when we have an angle, but we don't know what it is. Okay? So I'm calling it theta. Alright? I should really call it theta degrees. Now, how do I find out what the size of the angle is? That's the angle of elevation. Okay? I'm going to start off by writing that that mnemonic device we used to remember. Yes, SOHCAHTOA, good. The more times you write it, the less times you'll need to because it just gets stuck into your head. Okay? Sine, cos, and tan. Which ratio are you going to need this time? Yep.
Sine.
It's sine. How do we know?
The opposite.
Sine's right. Good, you can see it. You're starting to get the hang of it, aren't you? Right? If this is the angle you got, this side is opposite, and of course the hypotenuse is the longest one. Okay, great. So now we can write out a number sentence and equation that matches up to this, right? You said it was sine. Right. Sine of what?
Sine of theta.
Of that angle, right? Yeah. Which we don't know what it is yet. Okay, so that's fine. You just write down theta degrees. And it's opposite on hypotenuse. That's fine. There's the ratio that we've got. Okay. Now this is different to the ones that we looked at earlier because we're trying to find an angle. We're not trying to find a length, right? So you need your calculator for this again. What we're going to get is theta degrees equals. Okay, now, to get the angle out of this, right, I want to get rid of sine from this side. It's going to become sine inverse, or shift sine on your calculator, on this side, right? So 69 over 80, there you go. And your calculator should spit out a number to you. What do you get?
Shift sin.
Sine. Yeah.
Why is there a -1 after sine? Like,
Yeah. Okay. So this -1, I'll get your number in a second, right? This -1 means it's the inverse or the reverse of sine, right? So this undoes what this does, right?
Well,
Which is why you get an angle. Sorry, say that again.
Why does it go on the other side?
Because I've done sine inverse to both
But it
sides.
shouldn't
right?
go on that side too.
So no, it's just the sine is what's gotten rid of, right? It's just like if you had, say, example, the square root of x equals 5. You would square both sides here, wouldn't you? And you'd get, what's the square of this?
X.
It's just x,
Okay.
right? And then you get 25, right? So the x hasn't come over, just like the theta hasn't come over.
Oh,
It
so-
stays put.
So, but if we did, if we want to put sine and theta both on the other side, so it'd be sine theta in inverse minus 1.
Yeah, you could divide by the whole thing, but that's not what we're doing. Okay, now, Jake, have you got a number for us? Can you read it out for us?
59.59845234.
Okay, that's cool. All right, good. So you got a whole bunch of decimals there, right? Now look carefully at what the question is asking you. It says, oh sorry, yes.
Oh, okay, 60.
Okay, now, before you answer, before you know how to approximate, you've got to look at how the question wants you to approximate, right? And it says, answer to the nearest minute. Nearest minute. Now, you got to think back to last term on this one. We dealt with these, right? Minutes are a way of dividing up degrees, okay? So just like you divide up hours, right, into minutes and seconds, right? It's exactly the same kind of division. We're dividing up not hours, but degrees. Which is why some of your calculators will have a DMS button, right? Which divides things up in exactly this way, okay? So with this still on your display, right? You want to hit the degrees, minutes, seconds button, which is the one, it looks like this. If you remember this, I think it's something like this. All right, so you then get another number. What's the readout?
Oh, I just closed it.
59
degrees.
Yep.
35 minutes.
35. Wait, anything else after that?
And then 54.43.
Okay,
But
I'll just write out the whole thing.
And then it has this, yeah, that's it.
Okay, good. So, look at it with me, right? I'll even get another color out, okay? It's degrees, minutes, seconds, right? You recognize that's the symbol for degrees, right? The next one is the symbol for minutes, and the next one is the symbol for seconds. Okay, now be super, super careful here, right? You've got degrees, minutes, seconds. I want to the nearest minute, okay? So the nearest minute. So this is either going to stay 35 or it's going to go up to 36. Should it go up or down?
Up.
It should go up. That's exactly right. It's going to be 59 degrees, 36 minutes. Okay? Now, it goes up. You're kind of lucky on this one, right? Because why did you tell me, why were you so sure that it goes up? Yep.
Well, I know what you're about to say, because it's usually above 50, but in this case it's 30. 'cause
Yeah,
it's
okay, all right.
60 seconds.
So, good. Let's rewind a little bit just in case you weren't there yet, right? Usually if you see something like 30.1, give an example, 1.5, okay? If I said round this to one decimal place, actually I'll give you an even easier number, okay? If you were to round this to one decimal place, what would you get?
31.
32.
32.
One decimal place, right? So
Yeah.
the 30 is going to stay there, and it'll be 0.2. Good, that's fine. And the reason why is because you've got this 1.6, and it goes up, right? Now if I give you another number, 30.13, okay? And I'll ask you again to round it, right? One way or the other. This time it's going to round
30.1.
down. Okay, good. And the reason why is because the threshold is 5. 5's the middle. This is above 5, this is below 5, and that's the results, okay?
So what's 5 itself just up?
Well, by convention, unless
It always
you're
goes up.
unless you're a banker, it goes up. I'll talk about that another time. Now, here's the problem though. Here, you'd think, 54 out of like, well, we usually would think decimal. So 54 is like out of 100, right? But there aren't 100 seconds in a minute.
60.
There are only 60 seconds in a minute, right? So let me just give you a different example. Suppose, instead of this being on the readout, okay, you got this. 59 degrees, 35 minutes, and 32 seconds. Okay? Now, if you saw this 30.13, you'd say, okay, round down, no problems. Okay? But look, this is seconds. Is this closer to 60 seconds or is it
Yeah.
closer to 0 seconds?
60.
And the answer is it's closer to a whole minute than not a minute, right? So this, that would round down. Right? Sorry, that would round up. That's what I was saying. There you go. Okay, just like this rounds up. So you've got to be careful. That's why this was the answer I had on the board at the end of the day.